video, we will talk about distribution of intelligence in specific population. We have seen that when we talk about a large and diverse population, the intelligence is likely to be distributed randomly. And as we know that anything which is distributed randomly usually takes the form of a normal distribution or bell curve. So, in a large population, distribution of intelligence is symmetric. Means that roughly half of the population is above the average and half of the population is below the average. And at any point on that scale, if you take two sides, for example, if you take number of people who have more than one standard deviation above average score, it will be roughly the same as number of people who have one standard deviation below the average score. So this is how intelligence is distributed when population is large and diverse. But what happens when the population is small and homogeneous, not that diverse? For example, take the sample of IITians. Now, is it that intelligence is supposed to be normally distributed among IITians? From common sense we can say no, it is not. Because what happens is that if a person has got an IQ of less than 115, the chances of that person getting into IIT is very less. So actually the minimum will start from almost 115, and then between 150 and 125 there will be like 90% people, and that distribution will not be normal, but it will be very much skewed. So if we take a sizable sample of IITians, what we can expect is that majority of the scores would be above the average, and then there will be some scores which will be very high, very distant from the average. Now this is a positively skewed distribution. So if we take any specific sample from a larger sample, we don't get especially if we are selecting the sample on the basis of some predefined criteria, we don't get a normal distribution. We get a skewed distribution, we get fat-tailed distribution. And then the logic or the idea of which we apply at normal distribution do not apply there. So we need to use different kind of statistical measure to basically study and examine the differences between people in that population. Secondly, there is a concept called range restriction, and range restriction is simply that. Just take the example of school going kids. Now, if I want to measure the population of let's say intelligence of a population, ideally what I should do is that I should measure all the people from 18 year to 60 year, 75 year maybe. Then I will get the whole population distribution. But what happens is that as a researcher I don't have access to all, because most of them failed high school and they are sitting at home. I don't have any access to them. Or I have access to specific schools. So what is happening is that the range is very much restricted, and because of that my measurement will not be that accurate, because what will happen is that it will systematically select or reject or let's say label high or low to a large group of people. So if I select IITians for example and I give my test, most will score high. It means that my test will have low difficulty level for IITians, but if I take the same test and give it to high school population, then my test has very high difficulty level. So when we are basically interpreting the scores, or when we are evaluating the quality of a test, we should look at whether it's standardized on a specific population or a general population, and based on that then we should take a decision of where to apply it and where it is most applicable. So these are the nuances of distribution of intelligence in small population and how it impacts the measurement of intelligence. Thank you.